So now I want to talk to you about Newton's second law, and in particular too, net force. What net force really means, because I've used this term a lot, but I don't know if I've necessarily clearly defined it for you. So Newton's second law, there's a wordy version of it, but the simplified version is just net force equals mass times acceleration. Basically boils down to an equation. If you look on the reference table, you'll see it written as this: A equals F net divided by M. It's the same equation, just rewritten in a slightly different form. So this tells you a couple things. If there's an acceleration, there's going to be a net force. If there's one, there's going to be the other. And how much of it depends on the mass of an object. Similarly, net force and acceleration, because they are both vectors, are always in the same direction. So where you have one, you always have the other. Now let's look at some applications of this. But to do this, I also want to describe what net force is. So net force really is a resultant, if we think about it in terms of vectors. The net force is the result of adding together all the other forces. Now I talked about different kinds of forces like tension and normal force and gravity that push and pull on objects. There is not a force called the net force that pulls on an object. The net force is a resultant. So maybe what you have is someone pushing on an object 4 newtons to the east and 2 newtons to the west. So the resultant of that, the net force of these two other forces, 2 forces are being applied, your net force is just 2 newtons to the right. And again, because it's a force, it has a direction. Let's say I switch this up. So instead of 4 newtons to the right and 2 to the left, I said, hey, let's have 5 to the left and 2 to the right. The net force, we just kind of add these up in our heads and say, hey, 5 left, 2 right is going to be 3 newtons left. Sometimes you might express this using a sign, a negative sign, to indicate to the left, so that could be considered negative 3 newtons as well. Negative 3 newtons would indicate to the left. Now you can do resultants in net forces in other directions. So you could do like your typical like 3, 4, 5 triangle, 3 newtons, 4 newtons. So your resultant net force would be 5 newtons. That's fine, there's lots of ways to do it. Just keep in mind that a net force is a result of adding other forces together. Now let's look at it then in terms of Newton's second law. Net force equals the mass times the acceleration. If I have an object here, I'm going to draw this, and I say that it has 5 newtons to the right, and it has 3 newtons to the left, and it is a 3 kilogram object. I can say, hey, I look at this and I know that the net force is 5 right, 3 left, 2 to the right. So 2 newtons is the net force. It's a 3 kilogram object. And I could solve for acceleration. Acceleration then becomes 2 newtons divided by 3 kilograms, which is 0.67 meters per second squared. Now remember, newtons can be written in terms of kilogram meters per second squared, so the units, trust me, work out on this. I encourage you to do this on your own if you're not completely sure. But if you remember accelerations in meters per second squared, it makes everything easier. So there's different ways to get net force and mass. The easiest, of course, is if you know that it's balanced, right? So balanced, imagine I say something is moving at a constant speed. And you're using 5 newtons of force to pull on it. You can say, hey, if it's balanced, then I know that the net force has got to be 0. And if it's 0, then I can say, hey, I'm pulling on it with 5 newtons. What do I think the force of friction might be? Well, it's got to be equal and opposite. So the force of friction has got to also be 5 newtons. It's got to be balanced to the right and the left. Eventually we're going to start talking about this in 2 dimensions as well. So in this case, 5 newtons right, 5 newtons left, net force is 0, constant speed, acceleration is going to be 0. Because you get 0, net force equals your mass, which is 3 kilograms, times your acceleration, but anything times 0 is going to be 0, so your acceleration is 0 meters per second squared. Final example here. Let's say I know there's a frictional force, but I don't know what it is. But I do know the acceleration of it. Let's say the acceleration is equal to 2 meters per second squared. I can work backwards. One of the tricks in figuring out these problems is figuring out the best way to work. So I can say net force is then equal to mass times acceleration, or in this case 3 kilograms times 2 meters per second squared, which would be 6 newtons. So if the net force is 6 newtons, oh, there's a problem right here. I can't have 5 newtons to the right and some number of newtons to the left, because that can't reach 6. So maybe instead of pulling on it with 5 newtons, I pull on it with 10 newtons. And I know the acceleration is 2 meters per second squared. And then therefore the net force is 0, and I say, hey, I'm applying 10 newtons to the right. What's the frictional force? Well, we know that 10 newtons to the right minus your force of friction has got to equal 6 newtons. Based on the acceleration of the mass, we know that. So therefore, your force of friction has got to equal 4 newtons. Trickiest part is always figuring out which way to go, because there's lots of ways to figure this out. Do you figure out the net force based on knowing the force vectors? Do you figure out the net force based on the acceleration? Do you figure out the net force based on the word constant speed, which tells you that the net force should be 0? There's lots of ways to do it. Just keep in mind that there's certain tricks that you will figure out throughout the year. Thank you very much for watching.